Okay, well let's keep rolling here. We kind of hopefully unearthed for you the start of interest rates and the market for borrowing. So we've got the island example where he's kind of in a pinch on whether he should build a net, and so having opportunity cost of taking him out of fishing, and if we could somehow transfer consumption from one time period to the next, ends up leading to this potential of somebody who can loan out some money and somebody who wants to borrow some money. So the demand and supply of loanable funds, the market here created kind of a natural demand and supply, which we've already done in the loanable funds market. And so as the interest rate falls, the price of money falls, then somebody's willing to borrow more. But at the same time, if the interest rate's falling, people don't want to give up their money, right? Banker Jen is going to be less and less willing to give up some of her money for the loan. And so the place where they find this happy balance is somewhere in the middle, through negotiations or otherwise, and they agree on an interest rate. So the interest rate is got a lot to unpack, a lot of things to take into account. What are some things that happen over time that affect the real rate of return? The real rate of return. When I say the word real, what am I taking into account? After inflation. So something to do with inflation, right? So both the borrower and the lender have to take that into account. We already saw that in previous chapters that we did. So we have that breakdown of the inflation. Once that's taken into account, what else does the lender have to account for besides inflation? Inflation is going to kind of affect both parties, but is it better to go into Bitcoin or better to go into a loan from your high school buddy, loaning money to your high school buddy that's trying to start a business? Or is it better to put it into mutual funds where the stock market, like the top 500 markets, the top 500 stocks like the S&P 500, what determines where Banker Jen should loan their money also? Jesse?
The place that has the highest likelihood of giving her a return.
Highest likelihood of giving her a return. Okay, I think you're dabbling on it there, but think about that. Bitcoin, loan to high school buddy, S&P 500. What am I trying to tease out here as far as there's a return factor? So let's put that in your pocket. Nope, not in your crotch. Put it in your backpack or in your pocket. What else does Banker Jen have to take into account? Track record. Okay, what's the track record going to reflect? And track record of like high school buddy, I'm guessing what you're saying, or and the track record of the S&P 500 and the track record of Bitcoin. Yeah, okay, that's the word I was looking for. The risk associated with it, right? So now you guys have probably heard this. If you take on more risk, what needs to happen to the likelihood of the return, or what has to happen to your expected return? If you take on more risk, you need more return to compensate for that risk, because it might not come as easy. That's kind of inherent in it. So the textbook has a nice little breakdown here of the kind of the key components to the interest rate. So if we negotiate an interest rate of 12%, so this is the money rate or the nominal rate of interest, two people agreed to 12%, Banker Jen and borrower Tom agreed to 12%. Well, what's all kind of wrapped up into that? Well, we learned in the last chapter we got to take into account inflation. So the real rate of return was the difference between the nominal rate and the expected inflation rate. That was the inflation premium that's being highlighted here. And then they're using the word kind of pure interest, or the real interest rate that the banker wanted to earn was this part. And now what we're adding on into this chapter also is that we need to pick something either holding risk constant. If I hold risk constant, then this upper bar kind of goes away. So if I take two, let's say German bonds and Japanese bond, we're talking government bonds. German government bonds, Japanese government bonds, and US government bonds have a track record, as Simon was saying, of all being, pretty solid that they're going to pay their money back. You see how risk isn't a factor if I hold risk constant? Then I'm back to this equation. It's just inflation adjustment. Might have been a somewhat bad example with using multiple countries, because what other types of risk would that bring in? German bond, Japanese bond, or US bond?
Maybe that their currency will devalue?
Yeah, the exchange rate, right? So we'd actually have a little exchange rate risk put in there that would be embodied in there. So I didn't mean to do that, but holding exchange rate risk constant, then we're just back to focusing in on the inflation. So risk needs to be factored in, and so it's called the risk premium. So if this is the Simon interest rate, if Banker Jen wants to go to Simon, but if she does her research and she's also considering Russ, and she knows Russ is a risky guy, she's like, I got to get 20% for Russ. And if all of this other stuff is constant, the expected inflation, then the premium on Russ was 8% higher than Simon, right? Russ was that much extra risk involved. And so the money rate of interest would have to reflect that. Okay, so any questions on kind of the breakdown? We kind of call this like a dichotomy, breaking down the interest rate. All right, so let's do an example here. We're building on yesterday. Of an investment here. So suppose you have the opportunity to invest in a gumball machine. For $290. It is expected to return $50 per year. For the next 3 years, and then can be sold as a used machine for $160 at the end of 3 years. Should you invest in it? What do you think, Lazar? Okay, so we'll make a profit. So what are you saying? We should do it? All right, so Lazar says do it because profitable. And how'd you calculate your profit, just to be clear? So it looks like you maybe did some cost of, okay. So you got 3 years at 50, right? At $50 a year. And then you've got the sale at the end of 160. Okay, yeah, combine those together. And we got 310. And what did it cost you? $290. And so what's the profit? $20. Is everybody cool with that? I'm hoping some people are not cool with it because that's not the right answer fully. If we were here yesterday, there's more to this story we got to be careful of. Justin?
I was gonna say it's probably not a good idea to invest because you have to wait 3 years and then sell it. It's just to get a $20 gain.
Okay, so Justin says, what about having to wait years for some money, but give up 290 today? Is that a fair recharacterization of your problem in general? So, what would we need to do to adjust those numbers? Look back in your notes from yesterday. What would we need to do to adjust those numbers? It's not really fair to compare this flow of money coming in the future, especially this 160 is 3 years out, versus my hard-earned money today. So what do we need to do? Look for other opportunities, okay? But we need to be able to judge this opportunity. So we do want to think about our other opportunities and then have to try to judge this opportunity. So what is $50 worth? So let's just put it a little differently. Let's add on to Justin. What's $50 worth 3 years from now compared to 1 year from now? So I mean, we could kind of also look at it this way. You know, what would you rather have? I'll give you an offer here. You can have this right now in your hand today, or I'll hold on to it, put it in my dresser at home, and give it to you 1 year from now. I promise. I'm good for it. What would you rather have? That's your only choice. I'll give it to you right now. I'm trying to flash it close in your face. You want it right now, or do you want it the same one, the exact same bill, 1 year from now? What would you rather have? Right now. Why? Because you have other opportunities to do something with it now, right? So $50 today and money today, holding other things constant, that's our positive rate of time preference that we had talked about yesterday. So now yesterday we ended the class talking about how to make that adjustment. How do I make the adjustment of $50 3 years from today versus $50 1 year from today? Today, it's of course worth $50.
1 year from now, it's worth more, and you get extra money. If we wait, that's what makes it worth it.
Yeah, but talk to me in numbers. I gave you guys a specific formula yesterday. Very specific. You should be able to plug and chug something. Nick, what do you got?
It was UV times 1 plus I. I forgot what that is.
Okay, that's okay. Number of years.
And then it's equal to future value.
All right. And then, but now I'm asking, well, what is something worth in the future today? So I want to try to find the present value of $50 today that's given to me 1 year in the future or 3 years in the future. So what do I need to do here? Future value divided by, get this chunk over here, 1 plus the interest rate raised to the number of years. So the present value of $50 in 1 year, so 50 bucks in 1 year, is equal to $50 divided by 1 plus this I raised to what power if it's in 1 year? $50 1 year from now, what would I need to raise it to? What's n? 1. It's the number of years in which you're getting the bill. Now, what I should I use? What is my interest rate?
12.
12?
That's the
3, so I'm hearing a bunch of different numbers, 3, 12. There's no right answer. It depends on, probably the closest thing is what, is it you, Justin, I think that said, what can I do with my money? If I had $50, or maybe it was when I was flashing the $50 bill, it depends on what you can do with your $50 bill. If I can take this $50 bill and invest it somewhere and get 10% rate of return, then that is my opportunity cost, right? So my opportunity cost of money is I. And so let's say it's 10%. So before I go continue on with this problem here, so PV is the present value of a future amount. FV is that future value. I is the discount rate or the opportunity cost of money. Also called the discount rate because we are discounting our future money by that amount. So it's an interest rate that's relevant to you today that reflects your opportunity cost. And then N is the number of years to get that future value. Okay, so everybody pull out a calculator. You can use your phone here, put it on airplane mode, but I want you to start being comfortable with calculating some of this. So let's do the first one. If you have something raised to the 1 power, what does that mean? This is 1.1 if we have 10%. So we got 50 divided by 1.1, 0.1 because this is percent, raised to the 1 power. If you raise any number to the 1 power, what is it? It's just itself. It's the same thing. So 50 divided by 1.1 is how much? Everybody pull out your phone, calculator, put 50 divided by 1.1, what do you get?
It's 45.45.
45. And we'll just go to the nearest penny here. So 45.45?
Yeah.
Did everybody get that? So I want you to start to have a little faith here and to start to understand where that comes from. Literally, this helps answer the question. If you feel like you could get 10% on your money, if that's how you really feel today, and I give you the deal, what would you rather have, $50 right now in your hand or $50 1 year from now, you would say, I want it today. But what I just figured out then, if your true opportunity cost was 10%, I would say, what would you rather have, $50 today or $45.45 1 year from now? What would you, I'm sorry, would you, what would you rather have? $45.45 today or $50 1 year from now? I said that backwards. So we're bringing the $50 back in time to the present. So now I'll give you $45.45 today or $50 1 year from now. What would you rather pick? The answer is you're indifferent between those two. If you do take the $45.45 and you invest it at 10%, how much do you have 1 year from now after taking the cash today? $50. You see how we're even, Steven? So we just equalize future money and present money by finding that present value. All right, so now let's kind of set up the whole problem a little bit better. So when you see a word problem like this, which you will on maybe your final exam or in your homework coming up, set up what I call the 3 phases of an investment. Question? Yeah, go ahead.
Is that formula with the present value where you find out the future value also, is it possible to calculate inflation with that?
You can use an inflation adjusted number. Yeah, use the real rate of return and then you've adjusted inflation. Okay, so the 3 phases of the investment. So the first phase is what I call the initial investment. How much money do you have to give up today? In the case of our gumball machine, how much is it? $290. So today I'm giving up $290. So I'm kind of out $290. And then I have a period of time, 1, 2, 3, of 3 years. And so I have this holding period. This phase is called the operating phase. The operating phase. And then at the very end, I have a terminal cash flow. And how much do I think I can sell it for? 160. So I can get a plus 160. And then while I'm holding it during this time frame, I have a plus 50, plus 50, and a plus 50. What's nice about this is it kind of lays the whole problem out. What I'm trying to determine is it worth it for me to give up this to get this? Does that make sense? Is it worth it for me to give up this today to get this into the future? Now, the future money isn't worth as much as present money, so I have to bring this stuff back to present day. So now what we're going to do is calculate the present value of the future flows. The present value of the future flow is the first $50 divided by 1.1 raised to the 1 power. The second year flow is $50 with the 1.1 raised to the 2 power, plus the third year I've got a double whammy here. I do collect the 50 of the last year plus the sale of the gumball machine gives me the 160. So combined together, it's okay to combine those. We can keep them separate, but if we keep kind of the year 3 all together, 50 plus 160 equals what? 210? So 210 divided by 1.1, but those are coming in year 3. I already calculated this one as 45.45. What's the next one? So now you got a square term. It gets a little crazy here with the cube too. But Why don't you guys pull them out, shout out your answers. I don't have this prepared ahead of time, so I'm relying on you. So we'll just, once you shout out an answer here, I'll try to get them down.
41.32.
What?
41.32.
For this one?
Yeah.
41.32. Do I have a second on that? Did somebody else calculate that one? Yes? Okay, so we got a second on that at least. And then what's this last one? We got 210 divided by 1.1 cubed. How much? 157.77. Do I have a second on that? Okay, we got another second. Okay, so those of you who are doing it on your own, you might have to do this for a test, so this is a good time to double check your work. It sounds like we got at least a couple people agreeing. Anybody not get this answer? Okay, so now first of all, check this out. $50 2 years from now versus $50 1 year from now, right? So it's reflecting that money further out isn't worth as much as the money closer in. And then we've got this 157, which is even under the 160 that we're actually going to get. So it starts to get pretty powerful, even with just a 3-year investment deal, to take present value into account. So now, what do we need to do with these three numbers to kind of get to our answer here? Or keep moving towards our answer. Yeah, we need to add them. And what'd you get?
244.54.
$244.54. Can I have a second on that? Second, okay. Should I buy the machine? No. The machine is going to cost me $290 today. And money in the future, to me, brought back to present day, is worth $244. So the conclusion here is, therefore, since $244.54 is less than my initial investment of $290, which is in present value terms, by the way. I just want to highlight that, right? It's $290 you have to give up today. So this already is today's value. There's no adjustment needed. So since this is true, then don't do it. Okay, any questions? Example number 2. What if your opportunity cost is 1%? Sorry, it's trying to be a 1, but then I put a dot in there. So now you don't have a 10% alternative. It seems like everybody's paying a crappy, my savings account only offers me 1%, and I don't really want to mess around with doing anything else. So if my opportunity cost falls to 1%, what do we get? So how's that going to transform? Let's just look at this piece for a second here. What happens? How does changing that to 1% does what to this equation? What changes? This one, the downside, what is the new number? 1.01, right? Because it's 1 plus 1%. So now, the present value is 50 divided by 1.01 raised to the 1 power. 50 plus 1.01 raised to the 2 power. 210, 1.01 raised to the 3 power. All right, everybody do it. Kind of scatter. Pick one of those. As soon as you get an answer, you can tell me first year, second year, third year. Once you have an answer, just kind of scatter. Somebody take the 3, somebody take the 2, somebody take the 1. Yep, just go ahead.
49.01.
Okay. Yep.
And the third one, 203.88.
And number 1. Yep.
49.5.
Okay. Should we buy the machine now? What do these 3 all add up to?
$302.39.
Should we buy the gumball machine?
Technically, yes.
More than technically, yes, yes. As long as we got, for this answer, assuming we've got good information, now we can be more confident than what Lazar started us off with, right? Why? Because I've taken into account my other opportunities investing. By adjusting the numbers by the 1% opportunity cost, I'm confident that, hey, this gumball investment does better than what I could do with any other alternative, right? I'm actually making more money than what I could do with my other opportunities. So therefore, since $302.39 is greater than $290, do it. So the present value shows you, present value using your opportunity cost shows you that you can't do better elsewhere. All right, so now look at this too. 10% opportunity cost, 1% opportunity cost. Which one gives you less incentive to save? So which one are you like, screw it, this isn't that valuable, right? So $50 1 year from now is still just $49.50. It's like they're almost equal, right? So there's not much incentive there. I would rather, the flip side would be I'd rather borrow the money, so they're pretty much equal here. We start to get, close to $5, $4.50. So it's reflecting, this discounting is capturing your other opportunities. Okay, questions or comments on that so far? Go ahead. Oh, you said no. Okay. All right. So we got one other technique here. So the present value. So let me put kind of conclusion here. Discounting future values is key to long-term decision making. In general, I would just say, when money flows over more than 1 year. So this strategy applies to anything now. So you can start to think of, should I buy a classic car? I used to have a 71 Chevelle SS 354 barrel 4-speed. I bought the car for $1,700, and I sold it 2 years later for $2,300. So that was from, I had it in high school basically, so from 1989 to 1990, I had that sweet car. What do you think that car's worth today? It was pretty hot. It was a sweet hot rod. It had the hood pins and the racing stripe. So if I would have held on to that, I've kind of looked around, probably be worth $25,000 today. You know, it wasn't perfect condition, but it was a nice car. So did I make a bad decision not holding on to that car? Right? So I gave up $1,700. I sold it for $2,200 in 2 years, but I could have waited another 30 years and got $25,000. So is $25,000, so let's say the surplus would be, I gave up basically the increment, let's kind of use easy numbers here, of $23,000. So one way to use this then is, well, what's the present value? What's the present value of $23,000 30 years from now? What's $23,000 worth 30 years from now? Those of you who got a calculator, this one, if you got the little functions to raise it to the 30th power so that you don't have to go 1.1 times 1.1 times 1.1. As soon as you get an answer, shout out, what'd you get, Dustin?
1,318.8.
Really? Who else? I want to get a second on that. Yeah, Caroline?
17,280.2.
How much?
17,280.2.
Okay, 0.2.
I got the first.
You got the first one.
Except when it comes to the decimals, it's 0.09.
0.09. But this was $1,318?
Yes.
Yes, and 0.09. I had somebody else get 0.09. I don't really care about the pennies for that matter, but 0.09. All right. So 17,000 sounds a little strong. Who had the 17,000? Did you do raise to the 30 power? That was you, Caroline?
Yeah.
So which one is it?
You accidentally.
Let's have more people calculate it. I want to get more confirmation here. You can raise that. Reagan, what'd you get? You got which one? The first one. So we got 3 check marks on the first one. So Caroline, maybe want to check your answer again. We got 1 here. So 23,000 divided by, you got to do this 1.1 raised to the 30 power. Do I got 1 more check mark here? 1 more check mark here. Okay. So it looks like we're honing in here. 1318. So Caroline, yeah, check your answer again. It almost doesn't seem right. Is that right? 23,000 bucks 30 years from now? It's probably right. Especially if 4 of you got it. Did you recalculate it, or you can, oh, you did get it. Okay, yeah, I figured you just hit a button wrong or something. So, did I make a decent move? Maybe, but the point is, when the further out you go, the more of a compounding effect. So this is all the compound interest effect. We're getting interest on interest as our money grows into the future. All right, so let me get the screen going. And actually, maybe before I put the screen all the way down here, I wanted to end this with, so to make decisions, use marginal benefit and marginal cost analysis with present value. So the present value under an investment thing is it's really the present value of the marginal benefit versus the present value of the marginal cost. So it's also possible that while I held the gumball machine, I had a cleaning cost. So every year every year you have to dump out all the gumballs, wipe out the machine, and lubricate the little cranks and stuff, right? And so what if there was a cost here of -$5, -$5, -$5? Then you'd have to kind of take those minuses into account, which you could do by just saying that this is 45. That would work too, by taking the present value. Or if you wanted to do them separately, then you're kind of like, okay, here's the present value. I've got $290 of the machine plus this maintenance cost versus the present value of the marginal benefits. Yeah, Nick?
Does the rate of time preference, is that involved in this too? Or is
Yes.
that all?
No, so the rate of time preference was kind of factored into your opportunity cost. So your other investments or how you value the time. And so when Tom was going to die if he didn't get fed the 2 fish, that means you have a really high value of having fish today because you'll be dead otherwise, right? But if you can just, I could do the fish, or I could go a little bit hungry, that valuing of the time preference starts to go down on how you value it. And so then we kind of see that here. The more you value things today on what you can do, the higher your opportunity cost is, the lower future sums are going to be, and meaning they're going to have a higher threshold. So also, let me just to go back to this, if it's 244 like we had here, and this is 290, and you're a negotiator, you might just say, hey, I'll give you $200 for the gumball machine. Right? And they're like, oh no, I can't do that, but I could do 220. Now, do you buy the gumball machine? Yeah. Right? Whereas you don't do that if you're not valuing the future stuff in the right way. Okay, any other questions, clarifications? So of course this goes to Bitcoin, goes to real estate. This is really the fundamental equation of finance. All right, so there's another way that you might see in your book that I think I'll put in your notes instead of just putting it on the screen, but I'll put it right here. It's really a special case, but sometimes it's a good rule of thumb. So let's put special case. So how much is $1,000 each year forever worth if your opportunity cost is 10%?
Infinity?
Yeah, infinity. So on your calculator, instead of doing 3 years or 30 years, we've got $1,000 coming in forever. So there's a shortcut formula to this one. So we have a shortcut formula, which turns out to be a pretty nice little shortcut. But again, this is a pretty special case. And that shortcut is the present value is equal to the future income stream per year, future fixed income flow, divided by the opportunity cost, the interest rate. So in this case, with my example, it's 1,000 divided by 0.10. If we're using 10%. And so what is $1,000 every year forever worth to you today?
Only as much as the year you done?
I need a number here. 10,000 bucks. It's just finance. It's worth 10,000 bucks. That might seem crazy to you, right? But what is $1,000 worth 30 years from now? Since some of you who just did the 30 exercise, just for fun here, what is $1,000 worth 30 years from now at a 10%? So you're doing the 1.1 raised to the 30. Those of you who did that other one, let's get a couple of you agreeing on it. What is it worth 30 years from now? $1,000. Just shout out an answer when you get it. How much? 57.3, 57.3, 57, yep, I see a bunch of people nod their heads. $57. So $1,000 30 years from now is only worth $57. And so if you do a graph of this thing, then what you're gonna find is the 1,000 is just gonna diminish off and then be, $1,000 50 years or 100 years from now is just pennies, right? So it basically disappears. So the idea of forever in the financial world disappears pretty fast once you get beyond 30 years. It gets to be pretty small. Okay, so kind of hinted at whether you guys should go to college or not, and so I want to kind of end today with the investment decision for college. Should I go to college? Is college a good investment? So here is and there's been a lot of economic studies on this, by the way. It still pays off is the good news for you, but it really depends on your circumstance. So we've got the direct cost of going to Ottawa University. So here's your tuition dollars of actual money out. Now, if you're paying that over a 4-year time, then from our investment thing, it's let's say minus 10,000, minus 10,000, minus 10,000, minus 10,000, right? So that kind of 4-year from freshman year to senior year, you'd have some sort of outflow of cash. Take the present value of that. That's this. Opportunity cost to college, what would this be? If you're not at college right now paying this money, what could you be doing? Working. So now where could you work? Low, no skill job. We talked about Walmart Distribution Center. Maybe you can make $40,000 a year. So then you've kind of lost this over the first 4 years, and now we kick in, and hopefully you start making money. Now you would have had a little time on the job, so your low, no skill job, maybe you got a promotion, maybe you got a few raises or something, right? But that leaves you on this track. And you probably flatten out over time. You don't have as many opportunities for higher pay in the future, whereas hopefully the college degree puts you on this track. And so now each year we just look at that earnings differential. The present value of this chunk hopefully outweighs these two chunks. Otherwise, don't come next fall. You guys do your own calculations. Come and see me if you need some help. But that's the story of the power of the present value. All right, we'll see you on Monday.
I think this is the nicest anyone's ever said. You could consider dropping out.
Thank you. I'm trying to say it, but